Good morning YouTube and the internet. Today I'm playing with tools. I've got my micrometer set here, and so I'm going to respec this crank. This is the one that, based on the vernier calipers, I've decided I should be using, but before sending it off for polishing, let's double check what we've got to work with the right tool this time. Good morning YouTube and the internet. Today I'm playing with tools to measure things like this crank. I was going to measure the bores with my bore gauge, but it doesn't have a battery in it, so I've got to go and buy a new one. Also, this is being recorded on the new camera, it's not on the phone or the old camera which couldn't focus properly, so we shouldn't have the audio problems that we've been having where the cameraman would keep running his thumb over the mics, and we shouldn't, nor should we have the problems with focusing and things like that anymore, except it may get a bit tricky when I try and show you the increments on these micrometers. These micrometers measure to 1/10,000th of an inch. These are very accurate micrometers. They're much more accurate than my ability to use them, I think. However, that's what I need to do the job. So here's the crank that I've chosen to use for the rebuild. I want to double check all the measurements I took, which are inaccurate because they're on the verniers, but this one was the thickest, it had the most on it according to that measurement. So I'll double check this against the other one over here before making that decision. So now what I'll do is I'll show you how to actually use the micrometer. So the first thing when you're checking the crank is the woodruff keys need to be at the top. That means it's a top dead center. That matters because you take measurements on more than one axis. So all I need to do is just quickly clean up these. Make sure we don't have any dust or debris on there because that will affect the measurement. 0.1/10,000th of an inch. A very small amount of distance. Same with the micrometers. And I'm going to have to turn my fan on, and it's going to make a whooshing sound. It's stiff shit, it's 40 degrees. It's too damn hot not to have it. So with a clean shaft and avoiding the oil hole, back that off a little bit. We try and get this perfectly centered. Oh, I thought I was in the oil hole there. And you just got to do this by feel. There's no other way around it. I'm a little bit rusty. I've used these tools before, not for a few years, so if you haven't used them before, I suggest doing something else, practicing with them. I've just recorded like a monologue about all the measurements and what I've done, and I just realised the camera wasn't on because I'm an idiot. Guess I'll go through it all again. The camera went flat. You're now hardwired in to power, so we don't have to worry about that happening again. My cameraman was lost to daily chores. Had to go get some shit done. I measured 2 measurements on all of the Conrod journal bearings, checking for taper. The micrometer itself is quite large, and you can't even see the crank in the shot, and you can. And I could only get sort of, you know, quite near to the center on both sides because the body of the micrometer was fouling on here, so to get an accurate measurement I had to come in a bit on all of them. However, it wasn't useless to take the 2 measurements. It was still the right thing to do. When you do it, you just, because one side's fatter with the locking mechanism on it, so you measure that side that way, measure that side that way, and then that'll get you as close to the edges as you can. Nowhere near the actual edge, but it's as close as I can physically measure. Now, don't panic, I will show you how to use the micrometers. I still got to measure all of the mains on this, so I'll set you up for that and I'll film all of that. That's fine. But I've gone through, I've taken 2 vertical and 2 horizontal measurements on each one of the rod bearings, and the results are all measurements but 1, 2, 3, 4 are exactly the same. That is 1 inch point 8887. I've got 2 that are 8886 and 2 that are 8888. Now, if we go and get the, here's the measurements actually here. I've written them down. So there's a front and a rear for each axis. I've only written down the last number because the measurements were consistent. You can see on the first one here, where's my pen? Other end of the page. You see here, we've got I've got the full number down there, 4 decimal places. Because they're all the same, I didn't bother doing that all the way through, because only the last number is relevant. Here's the factory service manual. What I've got, when you convert these, let's go back to these, you idiot. I've already done this once, you think I'd do it right the second time. Our 8887 measurement, which is our most common, is 47.97298 millimeters. The crankshaft pin outer diameter standard from the service manual is 47.961 up to 47.974. So that is bang on, it's in spec. Our lowest measurement was 0.8886, which when you convert it is 47.97044, still in spec. And our 0.8888 is 47.97552, also still in spec. And also 1/10,000th of an inch is probably still within my measuring ability. They may actually be 7s. When I was reading it, it was closer to the 7 than it was to the closer to the 8 and closer to the 6 than it was to the 7. So I ticked it over to that. So you can actually even tell slightly smaller increments than 0.10,000ths of an inch by the way that you read them, which I will show you when I do the mains. But I've also done some spot checks on the crank that came out of it, and it's under spec, just like the vernier calipers told me it was. And I've done some spot checks on this other crank here that was also in the running to go back in, or go into the car, into the new build. And it's ever so slightly, marginally smaller than this one here on the bench. So my measurements with the vernier calipers, while they were never good enough to order parts, you know, to determine the bearing clearances, to measure for assembly, it was never going to be good enough. They were accurate enough to tell me that that one was under spec, this one was the best, and that one was in between. This one is in spec from the spots that I've done. This one's the best, and the one over there on the bench that came out of it is under spec on every measurement I've taken on it. So, and not by a lot, there's not a lot between them, but it's enough to be out of spec. So that tells me that the vernier calipers were far from useless for the job I had intended, which was to give me an idea. So all the people who had a cry about me using vernier calipers, you can eat a dick, because they did the job I wanted to do perfectly. they told me I needed to start looking at the other cranks and measured the other cranks, and they said, oh, this is probably okay, better get your micrometers onto that when they turn up, and I have, and it's tip top. So the mains I expect to be all good as well. I don't recall there being any issue with the mains on any of the cranks actually. It was only the rod bearings that I had issues with. So now I've got you powered up and I've done all of the rods. I suppose I should sit you somewhere where you can see the rest of the crank, and I'll measure up all the mains, and I'll show you how to use the micrometer and how to read it, which is not simple. It is simple once you're used to it, but I sat here for friggin' 20 minutes trying to remember how to do it. It's been a long time since I've had to read them. So one of the good things about this camera is it's got 3 settings. It's got narrow, wide and medium. I've now got you on wide to be able to get all of this in. Excellent. Okay, so just like before, we have to clean the surfaces before we measure them. And before I put them back away, before I put them away, I will re-oil them, because if you don't, they'll rust, and that means there's more polishing to do. Now I'll have to read up on how much a polish will take off, because it still may result in a bearing size change, but I'll be able to determine that when I get the pistons, check the clearance at that point, talk to the machinist, ask them how much material the polish will remove, and see where I'm going from there. And number 7. Lucky number 11. I know you can't see my face. Just take that as a small blessing. So this micrometer is too small for those. Okay, these are 2 to 3 inch. This is a 3-inch measure. And let's check that these are reading accurately. This is much easier with the smaller ones. Let's do what the pros do. This is how you should measure it. Check it. Except you should put the side of the barrel of the measurements facing towards the guy who's got to read it. So give that a good jiggle and a wobble. Make sure it's in there nice and snug, and lock it off. You can either leave that in or take it out. And this is exactly 3 inches. You're going to be able to see that. It's exactly 3 inches. The way you can tell, let's hope you can see, is they start at 2, so it's 2.1, 2, 3, 4, 5, 6, 7, 8, 9 markings on here, and then a 0, which is 10. So if we were to go past that with the 0 marking here on this barrel, we'd know that it was past it. But that 0 marking lines up perfectly with the line through there, so we know that's exactly 10. Which means that's exactly 3 inches. To within 1/10,000th of an inch, and even better than that, because if this line can be slightly off and still not line up with one of the others, it can still be closer, so you can actually be marginally more accurate than that. So now we know these are measuring accurately. I need my book so I can record all the measurements, just like I did on the others. So we have a vertical axis, a horizontal axis, we have a front and a rear for each measurement, and we have 1, 2, 3, 4, 5, 6, 7 journals to measure, and we'll record each one as we go. So the first one, number 1, quite a lot smaller than 3 inches, but it's bigger than 2. Okay, so this really is a feel thing. You sort of got to wobble it around and maneuver it on both axes to make sure that you are reading flat on the surfaces, because it's a round surface, it's even harder. Okay, so you probably can't read this, and maybe I'll put a link to someone with a better camera who can show you it, but we know this, the baseline of this is 2 inches. So that was a vertical measurement at the front of number 1. It's 2 point. The 1 is visible there, so we know it's 1. And then there's small divisions here which you probably can't see, and it's there 0.025 each. So there's 2 of those, so we're up to 50. And then on this barrel there are number markings from 0 to 25. So we have to add to the 50 the number that lines up, that doesn't line up but falls short of the horizontal line on this barrel. So we've got 10 here. So we have 50 plus 10 is 60. 1, 2, 3. So it's 2.163, and then we get the 10,000ths of an inch from these markings around this section of the barrel. And this is literally whichever line lines up the best is your measurement, and in this case the 8 lines up the best. It's almost perfectly aligned. That is 8. So our final measurement for the first one is 2.1638 inches. And if I get my cameraman back later, because I don't know how well that's going to turn out, I'll show you again. But for now, I'm just going to measure these all. Now that I've got that baseline measurement too, I'll probably only record the last digit, because I don't expect there to be a lot of variance. So we make sure we take off the lock that we put on, which I didn't mention. Wind it back a little bit before putting it on again. Try and get it nice and square to start with. Just got to feel it out. Give it a wiggle, give it a jiggle. Move it around a little bit while turning the clutch. If it stops moving after a few clicks of the clutch, when you move it, then it should be right. So, same again, we know 2.156. So 2.16, I'll write it 2.16, 1, 2, 3, so we're the same to a thou, and then the one that lines up the best is 7. So that measurement, so there's a taper of 1/10,000th of an inch across that, and I imagine that's within spec, but I do have to double check that. So once again, I forgot to show you the lock thing. So when you're measuring, you have it in the off position. This allows you to spin the barrel. Once you've got your measurement and you're clicking away and it won't move, you lock it on and then it won't move. so it just binds it up, so it shouldn't shift from your measurement. So now we're going to go on this side so we can get closer to the edge, and I can sort of do it from a standing position up here because I can feel it, he says as he flips off the side. You got to make sure you don't get right in the corner because you'll be measuring the shoulder, and you have to make sure you don't measure on top of the oil passages because they're well, the diameter around them is smaller. Simple as that. So that's not quite right. Give it a jiggle. You lock it on to that measurement. Gently pull it off. So all I do at this point is I don't bother reading the first things. I just make sure that there's 1, 2, 3 markings above the 10 below the line, and then check which number lines up the best, and that's a 6. So, and that's the only number I'm going to bother writing down now is the last one, because I know that they're going to be the same. And I'm going to measure this one on this side to keep this bulkiness out of the way from the measurement so I can get close enough to the edge. So wobble it side to side, rock it back to fourth, lock it off, pull it off, realise you've just measured the wrong bearing because there's none of the barrel showing, and go again. Did I measure the right one before? I feel like I might not have. You'll know because you'll have seen this. So rock and wobble, pull off, and we're looking at 1, 2, 3 below the line, 7. So before I go any further, I'll use my phone, just sort of the internet-based converter. Just for those of you who don't want to watch me do the whole thing, I can't blame you. We have 2.1638 inches. Okay, 54.96052 millimeters, and our crankshaft journal diameter should be 54.951 up to 54.957. So that 7 number is pretty much bang on. Let's see what the 6 is. Let's see if that's under. No, it's 0.955, which is bigger than 0.951, and the 8 equals 0.960, which is smaller than 0.974. So I'm going to measure these all on camera. I might just fast forward it if nothing interesting happens, and then I'll show you the measurements at the end. It all depends on how long the video is when I'm editing it. And then I'll need the additional cameraman to be able to look at the focus on the micrometers to make sure that you can see what I'm talking about when I'm talking about the markings on the barrel. But for now, I'm just going to measure these up, record them, and confirm that it's right across all of the journals, not just the ones I measured already. Oh, a cameraman's here.
Dinner.
Dinner's here.
Also, do you want a big chop or a small chop?
Small chop. It's not much chop. Get it? I said it's not much chop. Okay, I've got my cameraman back and I'm just measuring number 3 main journal, so I'm going to give you a good close-up this time of it, and hopefully the light will be good enough that I can show you the barrel and the camera will autofocus properly and do all the things. We get on here, not too close to the shoulder, a bit of wobble, and a jiggle, make sure everything's square, feel it around, lock it off, pull it off, and if the light is okay here, we have 2 inches, we know, because it's the minimum, 0.15, 0.16, 0.16, 1, 2, 3. And then, so which is the same as the other, so I'm not recording any of that. Then we're looking at these markings on the barrel here for the 0.010ths of an inch. Is it going to focus? Come on, come in there. You see those lines here? The line that lines up correctly is the 0.010ths of an inch mark. So that is 6. So that number 3 journal is 2.1636 inches. Okay, so that's how you read analog micrometers. You can get ones with digital readouts, they cost infinitely more. These do the job just fine. So I'm going to measure up the rest of these. I'll put you back on the wide angle and back up where I had you, and let you know how it went. So, assuming I just fast forwarded through all of that and didn't just cut it all out, you can see it's quite a, if I cut it all out you couldn't see shit, but if I left that in when I edit it, you can see it's quite a laborious, time consuming task to measure them, but accurate measurements make for longevity of high horsepower engines. So, I got my measurements. I've got a bit of a bigger range than I'd like to have gotten, but I'll convert those now into metric and see what the internet tells me I've got. So we know that 2.1638 is 54.96052. We know that 7 is 95798. We've got a couple of 6s, we've even got 5s and a 4 here, so 6 is 0.95544, 7 94798. You know what 6s are, you know what the 8 is, you know 5 is 54.9529. Number 5 seems to be a little bit smaller than all the others, and that was fairly consistent. As far as in the other axes, in both axes it was smaller than the others around it. There may be nothing. I've got to see what the spec says. Yeah, and 6, 7, 6, 7, 6, 7, 5, 4. I've got a 4 here, which is a real concern on 5, which is 54.95. Nope. 1.95036. And a 9, which I think must be an error in measuring, but I measured it a couple of times. I kept getting 9, so I've written it down. 54.96306. 96306. Yep, and the trusty manual again. 54.951 is the minimum, and this 4 is 59.95036. So that is under spec by the smallest of margins. And at the big end we're okay, so the 9's still in spec. So this 4 is fractionally under, and the 5 10,000ths is in spec. So I'm going to remeasure that 4 a couple of times and make sure that that is correct and that I didn't do it wrong. So number 5, forward measurement horizontal. I'm just guessing where to put you right now. I don't have a fucking clue what you're looking at. Probably the toolbox over there. 1, 2, 3, 4, 5. Horizontal front measurement. Wiggle wiggle, jiggle jiggle. Wobble wobble. Click, clickety click. And my measurement this time is still 0.4. So I'll just try reversing the direction just in case it's something I'm doing with my hands. Fly. Tension feels good coming off it and everything. 0.4. So that one is ever so slightly under, which means I will need to repeat the process on that crank there, double check all of that one and make sure that it's not better. It's a little bit frustrating. One measurement on one part. Oh, now let's have a look at the taper. What's the taper tolerance? Crankshaft taper limit value is 0.005. It's 5 microns, which is 2 10,000ths. Look, 0.0002 of an inch. Yes, it is. You can't read that, can you? So, if I look at my measurements, I don't have anything greater than 2 10,000ths of an inch on the taper on either the mains or the big end bearings. So the taper's within spec, and I think you'll find that even with a standard bearing, the oil clearance for number 5 will still be in spec. So I don't think it's going to be a drama. I'll double check it. If it's going to be an issue, then I'll have to look at the other ones. and possibly having to have them all, have the crank ground slightly and running oversized bearings. So they're your options if you're under on one or two. But I think the oil clearance, once I get the bore gauge sorted, well, I mean, we know what it's going to be actually. That's a fixed measurement, pretty much. Get my discombobulator out. How do you drive this again? 2.27. That can't be right. Oh, because it doesn't have the friggin' bearing thickness in it. God damn it. I cleared my other thing. Who would have thought there'd be so much mass involved in building an engine? I would have. 1.8 divided by 2 is 0.21. Wait, times 2. Yeah. I fucked that up again somehow. 2 is 0.94, that's outside the service limit. That doesn't mean it's no good. Lots of people run bigger clearances with aftermarket engines because they get a lot hotter, potentially, have a lot more energy going through them. But it's not ideal for a starting point. Now, the bearing sizes go up in pretty small increments, so I may be able to, that was a small bearing, if I use a bigger one, 1 divided by 2, still no good. Ah, fuck it, I'll just fucking LS swap the thing. No way. I need to look into that a bit more and see if I may need slightly bigger bearings. I need to measure the block, the mains in the block itself to determine if that's needed, or one of the other cranks, because it's easier to get. I mean, it's easier to get oversized bearings for everything, but if it's more consistently the same on one, then I can just pick the bearing to make the difference. If it's a standout journal that's smaller, which it is in this case, it's only on one axis, so very close. But yeah, if it's one, then you're not going to buy 2 sets of bearings to put a different size bearing in that to change the clearance. So I'll have a look, but I'm going to assume at this point that between this and the block, the standard bearings thicknesses, they won't be standard bearings, they're going to be ACL race series bearings, will be within the oil clearance will be within tolerance, and that is all that matters. That's the most important factor. So as long as I can achieve that, then I'll use this crank. Short of that, I'll have to look at the other options, the other cranks, if I get that one, or I could have this ground and just run slightly bigger bearings across the board. So if I grind all the other journals down, have them grind all the other journals down a couple 10,000ths of an inch. It's not a lot, is it? But it's probably possible. And then run a bigger bearing across the board on that one. I'll have to wait and see. I did have a polish in my pricing that I got from them. They quoted to measure it and balance it and polish it is what I'd asked for, because I'd assumed I'd get away without grinding. But maybe I can't. It's not the end of the world. It's progress. I won't bother you with measuring the other cranks. I will measure them off camera, make my own notes as to which one's more consistent, and then when I get a battery for the bore gauge, I'll measure the bores on that block, I'll measure the main journals on that block, and I'll do the same on the other 2 blocks. Then I'll have a positive match as to which crank will go on which block, and then it can go to machining, because hopefully by then some pistons will arrive, some forged pistons, forged rods, ACL bearings like I said. I'll be running ARP head studs. The main studs are going to be factory. There are people pushing 800-900 horsepower through factory main studs, so I see no weakness there, and I'm not going to get anywhere near those numbers. So yeah, the ARP head studs is for the boost level I'm going to push, and I don't want the 30 pounds of boost lifting the head. So obviously the deck and the head and the block will be decked. And the ARP head stud should keep that down. That should be no drama. That should be well within their capabilities. And oil pump still a question mark. What I'm going to do there, and whether or not I put a collar on, and those sorts of things. And if I do, which type, you know, do I use grub screw, do I use pressed on, interference fit, you know, there's a few different options. So I'm going to call that a night. Spray some oil onto this thing, drop it back in the cradle, it sits in behind the head, close my windows, go shower and go to bed, and dream about making 500 wheel horsepower. Because it seems like a dream at this point. It doesn't seem like it's very close at all, and I'm really running out of time. Let's just hope the parts aren't delayed and that I can get into the machine shop quickly when I pull the trigger on that. Anyway, peace out. Thanks for watching. I hope you learned something. If you didn't, tough luck. Yay. How do you end a video? It's just, you know, that's why you got the outro thing, you know.